I am Brent Schooley. I'm here to talk to you guys about Objective-C bindings for your Xamarin iOS projects. Really excited to be here at Evolve. I've been in the community for a while and just kind of excited to come talk to you about something a little more complex than I think a lot of the sessions dive into. I'm going to try to keep it a bit at a high level. This is sort of an advanced topic, but we're going to go through how to get Objective-C libraries over into your Xamarin projects. I work for Twilio, and I recently did a bunch of bindings for our Twilio client library and built a component out of that. So that's kind of my background with this. I was also at Infragistics when they were working on their bindings for their Nucleus product. So I've done a few of these at large scale. It's a process, but we'll work through that process and sort of try to demystify some of how it works. But the motivation for this, right? So all of these numbers have a nice plus sign on the end of them, because these numbers are from a bit ago. But the 219 plus components in the Xamarin Component Store. That's pretty awesome. And that's for the iOS numbers. So there's more if you branch it out a bit. That was cool, and I thought that's great. That's a lot of projects that we can share. Some of them are premium, some of them are free. We've got some great things to work with. But then I went and started to look around in the iOS world. So almost 2,700 Cocoa controls. So Cocoa controls is a great site to find UI widgets and controls for your iOS projects. It gets even more impressive when you look at CocoaPods. And CocoaPods has not only UI controls, but a lot of frameworks and library type code. Now, some of these are going to be written in Swift, some of them in Objective-C, so there's a bit of a split now. But most of that you're going to be able to use by creating bindings in Xamarin anyways. But that's a lot. That's a significant sum of projects that there are not components or not bindings available for. And I thought, I want to use those, right? I want to use those too. That's awesome. And I really, really would love to, but it's kind of like this foreign language, right? I don't quite get it, right? It's Objective-C, and it's got square braces and long method calls and sort of gibberish, right? So you end up kind of looking at these tools like an assorted set of kitchen tools that don't seem to work well together. I don't know how to use this in a project that's C# because it's written in Objective-C. So you kind of look at a project, something even as simple as this thing that I found called AY Vibrant Button, which just uses iOS 8's vibrancy effects to produce a button that looks good in the new vibrancy views. It's just got some properties. But even looking at properties, we've got @ signs everywhere. Even the name of the class itself has a prefix of AY, because Objective-C, until recently, has had a namespacing problem, right? So we've had to do these sorts of things to indicate unique class names. Non-atomic assign, I don't know necessarily that I want to think about what that means. I never have to specify that kind of stuff in my C# properties. And the names, there's a lot of repetition. Translucency alpha normal, translucency alpha highlighted. It's very wordy and verbose over there. What we kind of want is something a little more like this, more sane names, property syntax that we're used to. We can drop the namespacing because we have namespaces. So that's kind of like what we want out of this thing. So I thought, wouldn't it be cool if, sort of in a dream world, if I could take some Objective-C header, pass it through some magic box, and out would come a file in C# that I could use in Xamarin. That seems really cool to me. And it dawned on me one day that that's how Xamarin works. That's exactly how Xamarin works. Yeah, cue the fireworks, right? But that's exactly how Xamarin works. For all of the APIs that they bind in iOS, it's the same exact deal. Same exact stuff we're going to talk about here. That magic box turns out to break down into some interesting files that we can talk about. So API definition.cs. This is where all of your meat all the binding, all of the classes that are going to be part of your API in the resulting DLL, this is where you'll specify all of those. This is where all of the classes, all of the methods, all of the properties, all of that stuff's going to go in API definition.cs. And it has an accompanying file at sort of the root level, if you're thinking about it in terms of like side-by-sides, structs and enums.cs. So this is all stuff that doesn't require a whole lot of magic. They're just structs that you're going to reference in your API definition, structs and enums. So those will go in this file. And those two things combine into sort of what we can refer to as the core binding. So that's the main classes that make up the namespace for this binding. And then we toss in extras.cs. This is a fun file. This is where you can use the partial classes that are generated out of the API definition and extend them. So if you wanted to, say, make the API more sane for C# developers, maybe there's events that you wanted to add to the class, those would go in extras.cs. So it's sort of an enhancement file. And then the last piece that we have that goes into the binding is the native library. So a compiled static library, preferably a fat binary. That's something you can look up how to do in Xcode, but you want to build this static library for all of the platforms that you're going to support. So 64-bit, ARM, all the different flavors of that, so that they're all available to Xamarin Studio in the binding process. And all of those three things combined, core binding, extras.cs, and the native library, result in a DLL that you can reference in your code. So this will have all of the classes that you've bound and all of the extra APIs that you've added to it. Not going to hop over to Xamarin Studio to show much today, but I did want to give you a look at sort of a full, like, comprehensive look at what one class might look like, just so you can kind of see the structure. So this is an employee class inside of a namespace LOB app. So we need to have employee objects because we're going to track them. And it has a name, has a salary. It's got a method showing a method binding, showing a constructor binding. I'm going to break each one of those apart, but I wanted you to see a few things in this example. One of them is the name. So our class name is employee. But in the Objective-C version, if you look at the first attribute that's on the interface line, it says name equals XYZ employee. This is one really powerful thing that you can do with bindings. You can change the name of the classes in the original Objective-C library. And you're going to want to do that in most cases, because they're going to have these prefixes, right? So that's how you get at that at the object level. The rest of it I'm going to step through with minimal or smaller examples. So we'll just move to those now. So for binding methods, so again, this is over in our API definition.cs class inside of one of the objects that we're creating. So these two examples are from NSString. So we have a method. It's an instance method. That's what the little hyphen at the beginning means. And then it says it returns a bool. And it's called hasPrefix and takes one parameter, and that's a string. So note the hasPrefix : that is the name of the Objective-C method, of the selector, if we're being exact. That colon is important, and you need to keep in mind the colons as you move to API definitions.cs. First thing we do, it returns a Boolean, give it the name that we want, and we pass in the parameter. The attribute, the export attribute, tells the runtime, tells the generator what the Objective-C method is that this starts with method matches up with, and that's our hasPrefix : colon indicates takes a parameter. So notice I've named it something that makes more sense to a C# string class, right? The C# string has a starts with, it's not hasPrefix. So that's where you can kind of take the name that you see in Objective-C and kind of make it familiar to the C# developer along the way. So that's a simple method. Let's take a look at one that takes more parameters. So this is string by padding to length with string starting at index. That is a mouthful. 3 parameters, 3 colons. So the export statement says string by padding to length with string starting at index with the 3 colons. 1 word of advice. This process is error prone. It is prone to fat fingering. It is prone to forgetting colons heavily. And it's something you'll catch at compile time, but these names being what they are, lengthy, and having these colons you got to throw in, and the fact that it's a string inside of an attribute, just be careful when you're typing these things out. But I couldn't find a method on C# string that was anywhere close to what this thing does, because this thing will actually truncate and expand strings. It can pad things to the left, pad things to the right. So I just went with pad right, passed in the 3 parameters. But that's kind of the process for methods. It's pretty straightforward. Properties. I mentioned properties earlier. So we've got the at property, non-atomic, read-only, retain. The only thing we really care about out of those parentheses is the read-only part. So when we cut over, it's still the same export statement, just like you would do for a method. So it's title label, because that's what it was named over in the Objective-C library. And then we just declare our property like we would in C# with title label. But it's only got a getter, because it was read-only. If we had one that needed a getter and a setter, works exactly the way you'd expect it to. So we export out the name from the Objective-C library and create our property in C#. Constructors. Not surprisingly, constructors are a lot like methods. The difference here is the return type and one special rule kind of in the C#. But instance type is just a pointer to an object. And then we're taking a frame. So this is out of UIView's constructor, init with frame. So we export out init with frame, taking 1 parameter. The return type from a constructor, the signature is always the same for constructors. It is integer pointer, so that'll be a properly sized pointer to an object, depending on the platform that it's running on. The name of the method will be constructor, and then it takes whatever parameters were specified in the Objective-C. So in this case, it's just a frame. What's that?
It's not actually mapped to the constructor of the object.
It will actually. So the question was, it's not actually mapped to the C# constructor. It is actually, and this line in the binding is what's going to generate the extra constructors for you. Binding categories. So categories are a bit like extension classes in a way in Objective-C. So slight difference on this, taking a look at how that would look in Objective-C. So it's still an interface object. It's base class here in this case of UIView. And then the name of the category is my UIView extension. And then it just has one method that makes the background red. That returns void. So that's what the category syntax looks like in Objective-C. If you're binding that over to C#, couple things. So the base type, like you would specify on any object, and then an attribute of category to distinguish that this is a category object, a category on UIView. And then it's straightforward from there. It's basically just binding the method the way we talked about in binding methods. Blocks. So blocks are interesting. Blocks are ways to pass code around, often used in Objective-C for callbacks. So the block syntax is actually the only parameter to this method is a block here. And block syntax is so bad in Objective-C that there are sites foully named for looking up block syntax. It's blankingBlockSyntax.com. You can fill in the blank yourself. But there it is. So this is a block that returns a void that takes an object and a Boolean reference parameter. It's great syntax. Glad we don't have to actually use it. So first you need to set up that block signature with a delegate. It's the closest thing we can map it to in C# is a delegate. So we have a delegate, returns void. We give it a name so that we can refer to it. Oftentimes they do the same thing with type defs in Objective-C. So these block syntaxes that you need to translate into delegates, they'll often be type defed at the top of the library. Pretty easy to spot. So we give it a name, NSSetEnumerator, pass in the NS object and the reference Boolean parameter. And then we just bind the method, enumerate objects using block, and instead of passing in the ugly block syntax, we pass in our NSEnumerator delegate. So it's a one-to-one mapping. We're just using delegates in place of the block syntax. Protocols. All right, protocols are interesting. So they're similar to C# interfaces, but they support both optional and required methods, right? So in C#, our interfaces, the methods are required. So that makes it a tricky one-to-one match coming over to C#. And for a while, all the way up to Monotouch 7, I think, these were a little weird in the binding process. Thankfully, it's gotten better. If you mark the classes that are protocols, the interfaces that are protocols, with model and protocol attributes, the three things will get generated for you. And I'll show you what they look like. But three things will get generated for you by the binding engine. You'll get a class implementation. It's a bit like an abstract class, so you can override it. This is if you wanted to create a subclass of this protocol and use that directly and potentially extend on it. That's not the typical use case now because in Monotouch 7, we got an interface definition. So if you've used the table view delegate, table view source APIs, if you were looking before Monotouch 7 at how they're implemented in Objective-C, how they're used in iOS, you could adopt multiple protocols, but you couldn't do it in C# because there's no multiple inheritance, right? And we didn't have this interface representation to work with. Now, they're spitting out the interface representation. This is going to contain all of the required methods in the protocol. So if you only need the required methods, just the interface will be fine. But they also have a set of extension methods that get spit out. These are the optional methods in the protocol. So this gives you complete coverage with basically a very similar approach to using them, as you'll see if you look at Objective-C code that uses protocols. So it can make it easier to kind of go back and forth between looking at how things are described in some Objective-C documentation and how you might use it in Xamarin with the generated protocol. And it looks like this, like a full example looks like this. So we've got, it's a model, it's a protocol, and you put abstract on the required methods, and the optional methods, the standard way to go about putting those in, just bind the method. All right, so that is at a high level what bindings are. I'm going to cut to best practices, but before I do, I want to show you where kind of you can find out more information on this stuff. The reason I'm kind of cutting short on like going through all of the minutia is this is very much like going back and forth between English and French or English and Spanish, right? There's rules for verbs and nouns and sentence structure, and you can map pretty easily once you know the rules. There's great documentation on this that will help you figure out the rules. And from there, it's kind of a rote process. So going through an example would just be you watching me type a bunch. And I don't think anyone really wants to watch me type a bunch. But when you go to do this, this is going to be your first stop. This guide, Binding Objective-C Libraries. And you can get to it from the documentation pages. Go to iOS, go to Guides. It'll be down way towards the bottom in the Advanced section. And you're looking for binding libraries, right? So this will walk you through a very simple binding, and it'll go through an example of just about everything you can do to bind in an Objective-C library. So there's some things we didn't touch on that this will cover. if you really want to geek out on this, the binding types reference guide goes into detail on a ton of objects in the binding process. So you can kind of take a deep dive and see how this stuff is working under the hood. There's a great repository of bindings that people have done. This is, for me, this was like the #1 learning resource in this entire process. Taking a look at how things like red laser or any number of really complicated bindings, seeing how they actually did their binding will help you. Because you can go to this repository, say you're trying to do, you can't remember how to bind a block, right? Chances are you're going to find blocks across a lot of these things. And you can look and see, how did they do the binding? So the entire API definition and structs and enums files will be there. You can just poke around and see, all right, how did they translate this thing that's more complicated than what I'm trying to do? And you'll learn from that kind of experience. And those are all kind of curated and known to be working. So that's a good way to kind of get through this. And if you haven't had enough of Miguel, there is a session that he had done on binding that there are slides on SlideShare that cover a lot of this stuff as well. So my slides, his slides should have you covered in terms of the basics. So those are the resources. But what I really wanted to spend a chunk of time talking about is not the rote process, the minutia of going back and forth between what an Objective-C name is and what the C# name would be. But it's more the kinds of stuff that you're likely to run into when you do this, and things that you need to avoid or watch out for. And I have 2 examples that I wanted to share with you. And the first is to make sure that you expose events, especially around delegate objects. Now, I'm not talking about delegates in the C# sense. iOS has a really common delegation pattern in which an assigned delegate has methods called on it at a time when it's needed. So some object A has a delegate, and it needs to know some information, and it's going to ask object B that is of a specific type of delegate at a certain time. Hey, something happened. I need to know how many rows are in this table view, or what's the title for this row, or what's the subtitle for this row, right? That's a delegation pattern, and it's used all over iOS. We don't typically do things that way. It's much more natural. It's got a much more natural feel when you expose these things out as events. So when something is loaded, right, we would want a loaded event, perhaps, not something to get called on some other object to say, hey, I'm loaded, what should I do? Give me some data. So we're going to do events, typically. Now, here's a sample class. And that's a lot of words, so let's focus. This is the definition for that object. It's base type of object. Now, the 2 things that we've introduced in this base type guy that weren't in the simple examples earlier is this delegates and events arrays. So the delegate says, hey, this object in Objective-C has a delegate property, or has multiple delegate properties. And we want to map that, but what we actually want to do is map it to events. So what we're going to say is, hey, we've got this delegate, and we've got events that we're going to get declared out of this myClassDelegate object. So it's a little tricky the way this works, but if you look at the export statement, this property right here is mapping to the Objective-C delegate property itself. And you don't need to get bogged down in the details, but this weak delegate object in this class allows us to still do the delegation pattern if we wanted to. We're going to wrap it, but it's still going to be there for us. So we still wire that up, because we need to, because we still need to know how everything wires together. But we're going to wrap that weak delegate with the myClassDelegate object. And this is what's going to expose our events. If we take a look at myClassDelegate, that's where our loaded method, which is going to end up being our event, is declared. So the export statement says we're going to map a method called loaded bytes. So it's going to be the sender, so it's my class, because remember, this is being called from my class at some time, right? So the first parameter is my class, because he's saying, hey, I'm loaded, give me the bytes. And then the bytes are the second parameter here. And then we're going to have event args. So what we're basically telling the generator is, hey, I want a loaded event. And I want it to have event args called myClassLoaded. And then because of the previous wiring up with the delegates and events line, this is going to get added on my class, right? So we'll end up with myClass.loaded, right? That we can call in the C# code from these two things. So this is what ends up getting generated. We end up getting the event args generated for us. We end up getting the event handler generated for us. And that loaded event ends up on my class. So it's a much better way of working with this, I think, than kind of trying to follow the delegation pattern in iOS. And you'll see this a lot. This is one common pattern that you'll see used in a lot of Xamarin's bindings to the iOS APIs, where it makes sense. It doesn't always make sense. So you will see a lot of like override methods for like the view hierarchy type stuff. But on an object level, a lot of times, instead of doing delegation, you're going to see events. So that's one thing to think about, because you won't necessarily get this for free. There's a lot of things that you won't get for free if you just go straight by the book. You got to make a second or third pass on your bindings to say, is this really a good binding for my C# developers? And the other one, this is a big one, I think, and it was in Miguel's slides too. And when I saw it, I was like, yeah, I don't know if I want to talk about that. And then I realized that our Twilio library has this exact problem. And if you've worked with the mini hack at all, you probably pasted in the code and didn't think about it. But imagine if you didn't have the code to paste and had to figure this out for yourself. What happens is this pattern in iOS. Some method will take an NSDictionary, a loosely typed NSDictionary, as parameters, as options to the method. And it gets worse because it's usually string keys, right? So you've got string keys, so that's error prone. And then you've got this arbitrary set of objects. You don't necessarily know what the keys map to. You don't know what a valid key is, right? So it's not a great experience. It's really not a great experience at all. It's error prone because we're dealing with strings that we don't even know what they are, right? It requires extra documentation, right? And round trips to that documentation to make sure, hey, do I have the right key? Why is this not working? Why is my binding not working? Well, it turns out that you haven't given your users a reliable way to call into this method, right? Because you've just given this loose bag of stuff. And I think we can do better. And I think the Twilio client component can do better. So here's the example that I'm talking about. In particular, this is lifted straight out of the Twilio client bindings for the Twilio client component. And it's one method is what we're looking at here. And it's this connect method. And it takes an NSDictionary called parameters. So the direct way to bind it ends up we have to pass in this NSDictionary, and it's a mess. So it looks like this. And the syntax for this is like really bad when you start to use it. So NSDictionary.from objects and keys, and then a nice array of strings and another nice array of strings. That second array of strings is where we run into problems. You need to know that you're looking for source and target, right? And if you don't know Twilio, you can't figure this out in IntelliSense, right? Because you're having to pass in that actual word. That just doesn't work well in your API. And people will run into problems with this. And it's not hard to work around this. but it's another one of those things that you're not going to get for free in just the straight binding. A lot of people have thought, oh, well, I could write code to translate, I know that when I have a method, it binds like this, right? And you rip through and you auto-generate that first pass, and it'll work, but it's going to have things like this that you need to come back to. So the way to kind of fix this, this is the verbose way. There is a simplified way. I didn't make it into my slides, but this is what's going on under the hood when you implement the compact way of doing this as well. And it's instructive to look at it. The first 2 lines are just basically getting the object set up. But the thing is, we're using a dictionary container. So what this thing is doing is wrapping NSDictionary. And we're declaring the keys that the dictionary supports. And then, more importantly, we're able to do strong-typed properties on this parameters object. So instead of having my user need to know that the underlying key is source and the underlying key is target, I'm exposing to them a property on this connection parameters object of source and of target, and it's of the right type. And the getters and setters for those properties call directly into the NSDictionary methods that you would work with anyways. So you end up with a much better experience for your users. And the way you end up making this work, once you have that object declared properly, I didn't point out, but that first connect binding has an internal attribute applied to it. That means it's not going to show up in the binding. So we're completely hiding away the not so great NSDictionary parameters object. And we're wrapping it. So wrap just says, hey, sort of replace this guy. Make him behave the same as this guy. And instead of taking the NSDictionary, we're actually going to take our TC connection parameters object in as the parameters instead. And the cool thing with wrap, with the wrap attribute, is you actually call the method sort of in this. So on the first parameter, we check, since it's null allowed, we say, hey, do we have parameters? If we don't, null's fine. Go ahead and pass it through. In this case, it actually won't work, so you probably wouldn't want to do that. But if we do have a parameters object being passed in, we just call .dictionary on it. So the Objective-C library knows no different. We've actually passed it exactly what it wanted. We've passed it the NSDictionary. It just is sort of being hidden away from the user with this strongly typed dictionary container. So we end up with something a lot nicer, which is being able to create the parameters object and set the properties directly. That means IntelliSense. That means no fat fingering. That means no trip to the documentation. Your documentation is the code. I know what parameters are possible on the connection method, knowing this exists. So I wanted to talk about one more thing, because I led off with components and the relatively low number of components versus the number of libraries that exist that could potentially be components. So the idea around publishing a component onto the Xamarin Component Store is to save your friends some work, right? There are both free and paid components, so if you wanted to sell something, this is obviously a great way to do it. I don't highly recommend that if you've pulled the Objective-C library off of GitHub. That's probably violating someone's license. So remember to follow licenses. But it's such an easy process to submit. They give you everything you need, basically. A make script with some things that you edit that'll give you descriptions. You create a getting started and details markdown files that talk about how to use your component. And you've seen these if you've gone in the Xamarin Component Store for other components. But more importantly, it makes it really easy for others to use your work. It's really easy to pull these things right into your project. You just say, hey, I want to get more components. That's the component I want. You can search, say add to app, and it's going to pull it down, add the references for you, whatever. It's the easiest way to do this. And most importantly, I think, it saves someone else from having to do the binding again, right? So two things you might consider if you bind something that you think people will also find valuable. submit it as a component, and also submit it to as a pull request to the monotouch bindings repo. Right? Those are two great places for that to end up, so that you can seriously save someone some trouble. I know I wouldn't necessarily want to do this again after having done it like for a couple libraries. So if someone else has done it for me, that's great. So briefly, I work for Twilio. I just wanted to mention we are here as exhibitor sponsors. We do have a booth. If you haven't stopped by, stop by and say hi to us. If you're doing the Evolve quest, we are like one of the first stops on that path. So say hi if you come by. The beacon's on the TV. And also, we are in the mini hacks. So if you're doing the mini hacks, you will get a chance to use the Twilio client component. Please work through that one. If you run into problems, come to our booth. We'll help you work through it. Please ignore the NSDictionary parameters object. I haven't had a chance to put that in yet. But yeah, I'll open it up for questions. I appreciate you guys coming and learning about this. Yes.
How about automated tools for binding generation?
Yeah, so that's an interesting, it's a good, really good question. So if you were savvy to read the description for this talk, I mentioned one that used to exist called Objective Sharpie, and I had completely intended when I first put this talk together to show automatic binding generation, show bringing that automatic binding generation into your API definition.cs file, and then say, hey, it's just that easy. So the problem with Objective Sharpie is it was, best I've heard, was a side project. And they got the idea at Last Evolve to like productize it, and it didn't really get maintained. So the problem with Objective Sharpie mainly is it will not work for most things. Like you'll point it at a header file, you'll say, please, and it'll have numerous errors. And you'll have to know how to go to the Objective-C library to make some changes to even get it to kind of chug through it. And I think at that point, if you know enough to edit the Objective-C stuff, you probably are just going to want to do the binding. I think, though, this is ripe for having someone build something again. Because as you'll see, and as I mentioned, it is very straightforward. If I have this, spit out this. If I have this, spit out this. The problem is, right, you're going to have to go back to those and rename things. But it does cut down a lot of that heavy lifting type stuff. So I would say, yes, that would be great. Build it. Build it and I'll use it.
I have another. Okay, so my next question was, do you recommend implementing the entire API or just the narrow pieces that you intend to use?
Yeah. So absolutely do not bind the entire API. You don't have to, and you won't want to. If you're curious, if you want to see like kind of how we sidestepped around some of that stuff, there are parts of our library that we couldn't bind. Not that we would even want to, but like a lot of internal type classes, right? So depending on how the library is structured, you may end up with objects that are in some internal namespace that aren't supposed to be exposed publicly. It's absolutely possible to expose those publicly if you map it through correctly in C#. You absolutely won't want to do that, right? So we have internal classes that we've bound so that they're available in the binding, but then they're hidden away internal so that they don't show up, exposed in the DLL. There's all kinds of like odd edge cases around that stuff. It's a really good question.
So I've run into this situation before, and it's just more of a comment than a question, but contacting Xamarin and talking to someone like Rolf or anyone else that's on the does a lot of the binding stuff can be really helpful to expose strange properties in native libraries, but usually it involves a bunch of crazy marshalling, which is not my forte, so it's nice to have people on that side of the fence help with that.
Yeah, that's another great point. So you're likely to run into something. If the library is not extremely straightforward, you are likely to run into problems at some point. The Xamarin guys are really good at this. And if you have shown effort to like attempt to do this yourself and you're running into problems, like they will start an email thread with you that you will want to show people later. I have a few of them. They're mostly from the Android bindings, which that's a whole different can of worms. But yeah, we definitely had some serious discussions around the iOS bindings as well. They're fun. We have one up here.
How about the libraries written in Swift?
Yeah, great question. I don't know. You might have to talk to Xamarin, because every time I talk to Xamarin about that, they say, I don't know, it sounds fun. I don't know. So one thing I guess you could do is find some way to see the Objective-C representation of the Swift file, which Xcode will let you poke around. Might be one way to attack it. I haven't tried that yet, though. I don't know if anybody has tried that. Don't have a definitive on that.
What automation tools does Xamarin use, since they seem to do a really good job?
Here. So the question was, what tools does Xamarin use? What automation tools does Xamarin use? I don't know. Ask Xamarin.
I thought they used Objective Sharpie. You're saying it doesn't work very well.
It's probably an up-to-date internal. I don't know. Do you know? Does anybody know?
Command line tool bundled with it called btouch, and yeah. So there's a command line tool included with what was back when it was monotouch. I mean, it was always included. It's called btouch, and I think Objective Sharpie just uses btouch under the hood. It's just a GUI for btouch. So btouch will get you like 80% of the way there, and then the stuff that the manual binding is where you have to get the last 20%.
Yeah, I would say that's a good point. I forgot about btouch. So a lot of the problems, like a lot of the errors that you'll see spit out in Objective Sharpie, I think are because Objective Sharpie is not like completely handling the errors it's getting back all that well. But yeah, it's probably btouch. That's a good point. Anybody else?
With the unified API versus the classic API, are there any considerations we have to deal with for binding libraries?
Not that I know of. Anybody else? One in the back.
I don't know if this will take too long, but you said Android's a whole different can of worms. Is there a 30-second spiel on how Android's different?
It works differently. And I'm totally happy to take that completely offline unless anybody else is interested, but like we can talk about that right after. You get to know a little bit about JNI. It can be fun, especially if you're in a situation like I was where you need to hide things, or worst case scenario, your Java docs aren't great because it's going to look at those. There's a lot of weird issues with Android bindings. One case that we ran into is if the library is abstracted away too much to the point where it's exposing interfaces instead of classes in some cases, you will not get auto-generated events like you will from the straightforward. In a lot of ways, the Android binding process is easy. You throw it a jar file and you say go, and sometimes that works like straight away. It's when you need to start peeling away some of the onion layers and figure out why it's not working. But I can talk to you about that offline, show you how it looks. Cool. Thanks, guys. Like I said, stop by the Twilio booth if you have any other questions or if you just want to say hi. We'll be there.